Hello, good morning. Thank you for joining us in this lightning talk. My name is Julio Villarreal Pellegrino. Right now I am a principal architect at Red Hat. I lead architecture for North America on OpenStack.
And I'm Roger Lopez. I'm a principal software engineer at Red Hat. And today we're going to be talking about designing and deploying Kubernetes on OpenStack multi-site environment. And to kick us off, I'm going to pass it on to Julio.
Perfect. So why Kubernetes? And as this being a question that they answered day one with the foundation survey, in what kind of applications we're running on top to orchestrate of OpenStack. We are choosing Kubernetes for this experiment for the ability to deploy applications quickly and predictably, be able to scale applications on the fly, limit hardware usage to require resource only. Kubernetes provides a lot of portability of workloads. You know, like you could run the same workloads between different kind of clouds, public, private, or hybrid, and you could have a modular, pluggable, hookable, composable design. And also Kubernetes is agile by design. So these are some of the reasons why we are doing this Kubernetes on OpenStack presentation.
So why OpenStack? So a couple of reasons we've decided to choose OpenStack is one, its flexibility and reliability. So such as things as being able to add a control plane to handle additional capacity. Or for example, horizontal scaling, being able to add additional compute nodes for computation when you need more computational power and for your different workloads. We also chose it because of isolation and server management, being able to do things such as being able to move workloads based on availability zones. And also having the ability to create highly available OpenStack control plane. So by having a highly available OpenStack control plane, you also essentially have a lot of your different OpenStack services highly available as well. And then finally, having an API-driven as a service design, and the fact that OpenStack is very API-driven, and essentially you can use it to do things such as creating your instances and so forth through the command line. So with that, I'll pass it on to Julio to talk a little bit about the multi-site.
So multi-site, this being a pet peeve from OpenStack architects, you know, like how do we get to a multi-site design? So the way that we've been doing it on the field, we have multiple scenarios that we've been doing multi-site for our customers. Number one is multiple isolated OpenStack environments with shared keystone and horizon. This is a really common use case. The other one is multiple isolated OpenStack environments and a cloud management platform on top of that. That could be CloudForms, Scalar, or any of those. The other really common use case is to have multiple isolated OpenStack environments with shared keystone and replicated storage. And in this case, we do it with Ceph. And the last one is the stretched region deployment. You know, like the problem with this stretched region deployment is the heavy network requirement that they have, and we usually only go to this kind of deployments when the network requirements could be satisfied.
So here we're going to talk a little bit about the different OpenStack multi-site architecture environments that we potentially use. So one that we considered was having essentially this particular environment, which consisted of two data centers, data center 1, data center 2. And in this environment, we had essentially 3 controller nodes, 3 compute nodes, 3 Ceph monitor nodes, 5 Ceph OSD nodes, and 2 Rados gateways. And essentially within this, we had in our OpenStack, you have your internal OpenStack network, which is going to consist of your provisioning network, API network, tenant network, and then of course we had a storage network to handle our Ceph storage. The biggest things with the Rados gateway is we use Rados for the asynchronous replication aspect of it. And for our provider network, we actually use GRE network tunneling to ensure that there was connectivity communication between both data centers. So with this particular architecture, what we really used was this environment. It's essentially the same as what you just saw, but what we added was essentially having a shared keystone between both data centers. And what this allowed us to do is essentially have an API client authentication between both data centers.
Now, multi-site Kubernetes recommendations, and this is where the fun part comes, right? Here are some of the practices that we did for our experiment. We have 2 data centers, fairly close, like couple miles from each other. Full disclosure on that one. And number 1 is network and network latency. You know, like for what we test, you want to be under 2 milliseconds in this case in order to get a well-performing Kubernetes cluster on top of OpenStack. The other part is on your network, you need to have like high throughput networks. The third network requirement is a single network extended between data centers. The way that we did it, because we just use OpenStack networking, we did L2 over GRE in order to extend a provider network between the 2 data centers. Now, if you are using a commercial SDN implementation, like Nuage, you could probably have this capability built on the SDN. HA and fault-tolerant storage, in this case, we put the Kubernetes registry on Ceph, so we were able to get that replicated across the data centers and use that. And another important part is the top-level load balancer. In this case, I want to just call out for load balancing, and I want to call out for GTM, Global Traffic Manager in this case. Like you want to have the ability to load balance between both sides in this case, and persistent storage for all the container infrastructure.
Okay.
So this is how it looks in a nutshell. We put, in this case, our container platform that we used for this experiment was OpenShift. We didn't went full Kubernetes IO, but it's what is running behind. We put a couple master nodes, couple infra nodes in each side, a couple application nodes, using the load balancer in global mode, and extending the OpenShift network over that VLAN that we extend using L2 over GRE. And the storage registry, we put that on Ceph as an S3 backend.
And really, to sum things up, when you're talking about multi-site container platforms, there's really not a good design for this. The biggest issue that we have is essentially quorum. If you lose quorum on one of your data centers, you're essentially going to have a stale state for data. So this is probably one of the biggest issues that multi-site container platforms have right now. However, when thinking about multi-site regarding OpenStack, it's actually something that's very achievable to do. And it really just comes down to having a network that can handle the throughput between both data. For example, both data centers or multi-data centers in general. When you're thinking about your applications, it's so important to make sure that you're thinking about high availability for your application, not so much, obviously it's important for your infrastructure, but really you should be going with the mindset of how do I make my application highly available? And then, as I can't stress enough, or we can't stress enough, networking and making sure that you have low latency to ensure proper communication between multiple sites. And with that, we have some of the software we used here just to point it out. We use Red Hat OpenStack platform, Red Hat OpenShift container platform for our Kubernetes, Red Hat Ceph storage, and then for our management, Red Hat CloudForms. And with that, we're done. So
yeah, and we're going to post a video on one of our blogs where you could see a demo and applications actually going between Kubernetes sites and having a highly available deployment of a same application stack on both data centers.
Yeah. And with that, we'll be happy to take any questions.
Yeah, we have 2 minutes.
Cool.
Questions? Yes.
Did you, by any chance, explore the idea of using Kubernetes federation?
Yes, you forgot to mention that. Yeah, federation actually fixed the problem with the quorum between data centers. In our side, we are not there yet, but we are gonna get there. You know, like, and that will fix the problem with the multi-site Kubernetes cluster. You know, like the quorum issue.
So, in relation to the same question, the federation was did you check any actual applications which are stateful? Because I mean to say, a stateful set in the sense of database or anything. Has there been any testing done on that yet?
We did mostly web applications, so there was not like database components, and the way that we recommend to use databases is actually don't put a big database inside of Kubernetes, but we did some application testing, and we deployed a couple applications and failover, scale out, scale down, and actually it's on the video thing that we take down one of the sites and you could see the application is still up under the GMT.
Thank you.
Perfect. Any other questions? But if no more questions, thank you for coming by.
Thank you very much. Appreciate it.